session 4. The topic is going to be analysis of survey ranking data using Friedman and Nemenyi tests. And our presenter is Maheen Ramazani. A brief introduction of Maheen. She's a research data scientist in the Center of Transportation Safety at the Texas A&M Transportation Institute. She received her Master's of Science in Computer Science from Texas A&M. During her study, she worked as a graduate research assistant at the Population Informatics Lab, School of Public Health at Texas A&M Health Science Center. Her master's thesis was about record linkage, which is identifying the same entities across one or more databases when there is no unique identifier. Maheen's research interests include data science, data mining, machine learning, and natural language processing. All right, Maheen, the floor is yours.
Thank you for the introduction. Hello, everyone. Today I want to talk about the analysis of survey ranking data using Friedman and Nemenyi tests. This is an overview of my presentation. First, I give you a background about the problem that we try to solve. Second, we talk about the method that I used, which are Friedman and postdoc Nemenyi tests. Next, I show you our analysis result. And finally, I show you an R code example in RStudio. This presentation is part of a big research study that we are doing with Dr. Schmidt. The main purpose of this study is to understand U.S. resident preferences for which of their identifiable personal information should be used, who should use that, and with what purpose. This table shows us the options that we have. First column, you can see who will reuse people's data. That can be researcher in universities, nonprofit organization, government, or business. Then we have the different purpose that why we reuse these data. These include research, scientific knowledge, population health, identify criminal activity, marketing, and profit activity. And the source of the identifiable information that we usually use is educational record, health record, government program or activity, and economic activity like customer behavior. To understand people's behavior, we designed survey using Qualtrics and conjointly. We published those 3 times. First, we asked general population to do our survey, and we did that twice, one before COVID-19 and one after COVID-19 in February and November 2020. The reason we did that twice was because we wanted to see how people's opinion had changed after pandemic. And finally, we send this survey to IRB expert to also consider their opinion as well. These survey data has been analyzed using different groups based on age, gender, race, income, education, and other categories. If you are interested and like to know more detail, here are the link for our 2 publications. You please go and check them. But today, in this presentation, we want to focus in 2 questions from this survey. When we had these 13 options, these are the same options that I show you in previous slide in a table. We ask participants to rank their top 5 from these 13 options to see which of these options they are most comfortable with for a data reuse scenario. And in the separate question, we ask them to pick their top 5 for least comfortable options for data reuse scenario. Okay, in the ideal situation, we expect people to pick 5 of these 13 options and as their most comfortable options, and we can rank them from 1 to 5, which 5 shows the most comfortable option for them. And we expect them to pick 5 different options from these 13 and rank them as least comfortable. And we can code them from -1 to -5, which -5 shows the least comfortable option. There will be 3 options left. We will code them as 0 because participant didn't choose them in any of these categories. But this is not what happened, especially when you deal with real people in real world problem. I show you an example. Here is a participant's answer to these 2 questions. As you can see, the highlights are repeated in 2 questions as their answer. It means that person select the same option as both in their most comfortable list and in the least comfortable list. So, and we had multiple of these kind of answers. So we decided to analyze each of these questions separately. So we will code the answer like this. For the first question, which we want to analyze the most comfortable option for the people, we code the 5 options that they picked from 1 to 5. Again, 5 shows the most comfortable option for them. And the 8 options that they didn't choose, we code them as 0. Next, for the second question, we do something similar, but this time, because we want to analyze the least comfortable, we code them as -1 to -5, which -5 shows the least comfortable, and the left options would be coded as 0. Now let's talk about the methods that we use. For analyzing the ranking question, we usually use the Friedman test. This test is used to detect the difference in ranking across the group. We have to define a p-value for ourselves, and based on that p-value, we can see if the categories in the data that we are trying to analyze are statistically significant, are significantly different or not. If they were significant, there was significant difference in the data, the next step is using post-hoc Nemenyi test. This test do the pairwise comparison to determine which group differed significantly. I will explain each of these 2 methods in the next slide with an example. First, Friedman test. Friedman test is a non-parametric test. It is used to detect difference in a treatment across multiple test attempts. It's used for ranking data. This is the equation for Friedman test, and it can calculate the chi-square for us. Here, n is the number of samples that we have, in our case, number of participants. K is the number of group that we have, which is 13 in our case. And RJ is sum of the rank for each group. I can explain more about this in the example. After we calculate the chi-square, we can determine the p-value by comparing the test statistics to the chi-square distribution table with k-1 degree of freedom. Let's look at a simple example to understand this test fully. Here, suppose we have only 3 groups, only for simplicity. We have researcher, we have nonprofit, and we have government. And 6 participants has ranked these 3 groups for us. And these are their answer. Each yours is answer for 1 participant. Here we have 1, 2, and 3. 3 shows the most comfortable options for that participant. First, we need to define a null and alternative hypothesis. Here, our null hypothesis is there is no difference between these three groups, and the alternative one is there is a difference between these three groups. We define a p-value here, a threshold for the p-value, which is hypothesis is 0.05, and if our p-value is less than this number, it means there is no difference between the three groups. Okay, here is our example. We had this table. What we want to do is calculate the ranking for each of these categories, which is the last row in this table. How we do that? We just sum the we just calculate the sum of the ranking that we have from 6 participants. And we will have 9 for researcher, 14 nonprofit, 13 for government. This is our equation that we had. As I said, N is number of participants is 6 here, K is 13 here. I'm sorry, here is 3 because we only consider these 3 groups. And then R is the rank for each of these groups, the sum of rank for each of these groups that we calculate here. So we get chi-square equal 2.33. Now it's time to get the p-value for this. There are 2 ways to calculate the p-value. The first one, which is a traditional way or manual way, is look into the chi-square distribution table. Here we have each row is degree of freedom, which is number of group minus 1. Here we have a significant level, and our p-value is going to be somewhere in the range of these levels. Here is how we calculate our p-value. First, K is 3 in our case, so the degree of freedom is 2. What we want to see is somewhere in the row number 2. Now, our our chi-square was 2.33. So it should be, our p-value should be somewhere between these two numbers, which is 0.9 and 0.1. This is a traditional way, but what I use now is R packages that I can show you in my code later today. These R packages and other modern tool can calculate the exact p-value for you based on your chi-square, degree of freedom, and your n. So the p-value for our example is 0.03, and which is more than p-value that we define as our threshold. And because it is more than that, it means there is no statistically significant difference here. Okay, this is for this this example that I show you. There was no significant difference, but if there were, the next step would be using post-hoc Nemenyi test. These tests usually will happen after a significant result from the Friedman test. We use to determine which of this group has differ significantly. It does the pairwise comparison among all of the group that we have. Here are the steps that we do in post-hoc Nemenyi test. First, we calculate a critical difference, CD, with this each equation. Again, N is number of sample that we have, K is number of group that we have, and the Q is critical value. Again, there is a table, distribution table, that we can get that from that table manually, or we can use online tool or R packages to calculate the Q. After we have a CD, we should compute the pairwise differences between rank sum. I will show you this in an example. And the next step would be compare the difference between what we have from step 2 with the CD that we get from step 1. And if the difference exceeds the CD, the pairwise comparison is significant. Here is an example. So our previous example, was not significant, but we changed that a little bit so we can get a significant number and do the postdoc Nemenyi. Suppose we have k equal 3, number of group are 3, number of participants are 5, and p-value are 0.05. This is the number that we get from the queue, from the table, or other software or packages in R or Python or any programming languages that you want to use. Using the CD equation, we get CD equal 1.624. Now it's time to calculate the pairwise differences between rank sums. So suppose we have rank sum 9 for researcher and 13 for government. The absolute value of the difference between them is 4. Because it is more than the CD that we use, the result is significant. Next, go for other group, nonprofit vs government. Here we have 14 as a sum of rank sum for nonprofit, and we have 13 for government. The absolute value of difference of them are 1, which is less than the CD that we calculated. So these are not significant. So this is the theory for post-op Nemenyi test, but again, modern statistical software, including R, doing that very easily by creating p-value in the result. So instead of dealing with CDs and Q and all of these numbers, the result that we get from this software, including the package that we use in R, is only p-value. I can show you in my next slides. But using p-value is more straightforward and it is easier to interpret. If the p-value that we get from the software is less than what we have as a threshold, for example, 0.05, or in our study we use 0.001, it indicates significant difference between the groups. Now let's move to analysis result. Remember these two questions that we defined in the table? We had certain options. We asked participants to select their top 5 and bottom 5 from this. And we coded our data based on these numbers that you can see here. First, we do the Friedman test to see if they are statistically significant difference in the data. So when we run our code, our R code, using the package that I show you in the RStudio, we get this chi-square, 590.28. This is our test statistic. We had 13 groups, so our degree of freedom would be 12. And this is the p-value that we get from the software. This p-value is less than 0.0001, which shows the significant result, and it means to see which group are significantly different, we need to run the post-hoc Nemenyi test. And here is the result of post-hoc Nemenyi test for this. So as I explained, these tests do the pairwise comparison between each of these categories. For example, this number is the p-value for comparing these two groups, research university and government. As you can see, it's less than our chosen p-value, which means there is significant difference between these two categories. But there are other categories that are not a statistically significant difference between them. For example, research university and scientific knowledge are the p-value are much bigger. So it means these two are similar, are not different. Now, we can use these results and these p-value in this table to categorize our group and find similar group together. Here, based on these numbers that we have in this table, we can see that these three groups, research university, scientific knowledge, identifying criminal activity are the same, and the rest will be in other category which are different from the first group. So we got similar group, but to understand which of these categories are people are most comfortable with, we can use the average score that people gave to each of these categories. As you can see, research university, scientific knowledge, identifying criminal activity has a bigger score here, bigger average score here, which means which means these category number one, people are most comfortable with, and the others have a less average score with a big gap between them. So you can clearly see the different group here in the mean as well, because there is a big gap between these two numbers. And these are going to the next category. Okay, next, let's do the same process for the least comfortable question. First, we do the Friedman test. Here, we have chi-square equal 508.41. Again, we have 13 category, so the degree of freedom would be 12. P-value is 2.2 e minus 16, which is less than 0.0001, which was our chosen p-value for threshold. That means the results are significantly different. So the next step would be using post-hoc Nemenyi test. Again, here we have the p-value for pairwise comparison between each of these group that we had in the data. For example, this first number is the p-value when we compare these to government and research university. In the previous question, the most comfortable question that I show you, the number p-values in the table was clean and good. It was easy to categorize our group into two groups, but here the results are more complicated. For example, as you can see, we have repeated group in different category. For example, let's only consider first column here. Everything that is less than 0.0001, we consider them as different from research university and one group, and anything above it we will consider in a similar group. For example, for research university, government, nonprofit, scientific knowledge, criminal activity, source government, and source education would be one group, and the rest would be other group. But when we go to the next column and do this process again, we see that government is similar to nonprofit, scientific knowledge, identifying criminal activity, profit, source government, source economic, source health, and source education. And the other three would be in the different group. So there are overlap between the group in the category that we define with each of these columns. And even when you consider the mean of the score of each of these group, you can see that these numbers are very close to each other, and in any level you cannot find a big gap between them. So this is an example where we cannot perfectly define some category or similar group, put similar group together. Now I'm going to show you an example in R. Okay. Can you see my R code? I cannot. Oh, okay. Thanks, Michelle. Okay. So tidyverse.
Excellent.
What?
I just completed.
Yeah, if you could make the font a little bit bigger, that would be great.
Is it bigger now?
Not by much.
Oh, there we go.
Oh, yeah, there we go.
Okay. Good. This is the tool library that we use. The first one, tidyverse. You probably are familiar with it. It's the main library that we use to work with data frame in R. And the second one, PMCMR Plus, it's the library that we use to work with these tests, Friedman tests, and post-hoc Nemenyi test. First, we read our data. Okay. The first row of our data is more detail about the questions that we ask in the survey, so we don't need them. I'm going to eliminate that part. Next, I want to select 2 questions because this data, let me show you, this data is a big data set. There are a lot of questions, but for this presentation today, we only need 2 questions. So I'm going to only get the ID of a participant and those 2 questions. And then there are some pre-processing that we do in the data. For example, convert them from character to integer and vice versa. And then we are going to code our data based on what I show you in this slide. We want to code for the most comfortable question. We want to code the answer from 1 to 5, when 5 shows the most comfortable option. And for the least comfortable question, we want to code the data from -1 to -5, and -5 shows the least comfortable option. And then we are again some pre-processing to show a better naming for each column. Now let's see our data. So we have PID, which is our participant ID, and we have our group here. The first one is research university, government, business, nonprofit, scientific knowledge, criminal activity, population health, marketing, profit, source government, source economics, source health, and source education. As you can see, for each participant, this is only data for the most comfortable question, so only consider first question. For each row shows the answer of each participant. For example, this one, select research university as their the most comfortable option to reuse their data. Then they chose the nonprofit. The third one is identifying criminal activity. Next, scientific knowledge. And the last one is source economic. And the rest, 8 options that this person didn't choose, we code them as 0. And we repeat this process for all of the other participants. This is the data for the IRB survey. We had 102 participants here. Okay. Now we are going to eliminate the first column, which was the participant ID, and use the rest of our data to run the Friedman test. This is the output for the Friedman test, the one that I show you in this slide. So here, for the most comfortable question, the chi-square is 519.28, degree of freedom 12, and this is our p-value. P-value is less than what we chosen as our threshold, so we are going to do the postdoc Nemenyi test. For postdoc Nemenyi test, we have to make sure that all of our data is factored. This is the piece of code that do that. And then we run the test. Again, the result of the test is here. This is the same. Maybe if I make it smaller and run it again, I will back to the bigger font when I showed you this is. So again, we get all of these number. This table compare each of these groups to each of two of these groups, like pairwise comparison, and these are the p-value for each of those. Okay, is it big enough? Perfect. Next, we want to see the average score for each of these categories. So again, as you can see, the first three, research university, scientific knowledge, criminal activity, all of these three has a bigger number, bigger average, and they are in the same category based on the postdoc Nemenyi result. So we can say that this is the category of groups that people are most comfortable to share their data with. And the other groups has less average score. Again, based on our post-hoc result, we put all of these others in the same category. And here, based on the average mean, we can say that people are less comfortable with these options. Okay. Now we do the same process for the second question. Let's see here. Again, for each participant, we have a row, and we have 13 group here. Each participant ranked this group based on their preferences. From -1 to -5. -5 shows the least comfortable option for them. Here in this example, business was their least comfortable option. Next, we had marketing, then population health, source health, and source education. Going back to the code, we run the Friedman test. The chi-square is 508.41. Degree of freedom is 12. P-value, again, less than what we define as a threshold. So we do the Nemenyi test here. So here is the result for the Nemenyi test. Again, each of these numbers are the p-value for comparing these two groups. Here for research university and government, this is the p-value, which shows that these two groups are similar. There are no significant difference here. But for research university and business, we see that p-value is much less than, much smaller than what we define as a threshold. So there is a significant difference between business and research university. Again, we can do the mean here. The mean, as you can see, marketing has the lowest mean. Scientific knowledge has the biggest. But overall, as I show you in this slide, all of these numbers, there is no big gap between any categories, and we also see that in the Nemenyi result that we cannot categorize these similar group together very easily. Okay, let's go back to our presentation. Okay. So we analyzed the survey ranking data to understand US resident comfort level with the various data reuse scenarios. We used the Friedman test to confirm significant differences in the in different groups using the p-value 0.0001. And if we find any significant differences in the Friedman test, we do the Nemenyi test to identify specific group differences. This analysis can help us categorize the group if possible, not in every single problem. Hey, that was my presentation. I hope it was helpful, and if there is any question, I will be happy to answer.
Thank you.
Sure.
Question, not about the math.
Whatever you.
Yeah. I wanted to add, I know you said it at the beginning, but what data is being shared for the patient? Like what the, like age? What, yeah.
So basically, the data that the data we are talking about, that who will use it and what purpose and in which data source, there are all the data that can be educational data, that can be health record data, government data, or economic data, which is customer behavior or something like that. And all of these can be involve PII, which is personal identifier information. That can be names, address, age, um, race, or any other PII that can be contained in any of these data source. So does that answer your question?
Yes, that makes sense. And the second question is, what does population health mean?
Can you repeat your question? Your voice cut off.
What does population health category mean?
Oh, maybe let me bring that out. I know that these categories that we defined here is based on, let me bring this, share this.
Wait, you want me to give the answer that I designed the survey?
I'm sorry.
I designed the survey, should I tell you?
Yeah, sure. Please go.
Yeah.
Population
Now, I
health
wanted
is
to share
meant
this
for
before
public health
you.
purposes. So
And
this is population health is in the purposes category. So are you comfortable with people using your data for marketing purposes, for research purposes, to increase knowledge? And population health is, are you comfortable for us to use your data for public health purposes, including population?
I see. I asked this because in the research or universities categories, it can include that.
Well, no, but it's different. You see, I
Those
think
are
research
who-
typically means increasing knowledge and information. Population health, specifically in this context, was meant for purposes of public health. Often in the legal tech context, those are not considered the same. So it is true. Applied research, it's not that the reality is it's not that black and white. But if you're writing a law, if you have a policy, then you have to draw those lines. And so research is the general definition of research across most laws is about increasing knowledge, new knowledge. Population health is about increasing population health through action practices, often thought of as public health purposes. Regan, since Casey's not here, you're here, maybe you have a legal perspective on this that you can share with them?
I'm sorry, was that for me?
Yeah, I was just wondering, you're here, so I was wondering, because you spent time reading laws that talk about, well, here's the data law, information law, there's an exception clause that says you have to get informed consent, but if you're doing it for research, then you get an exemption if you are doing it for public health purpose. I think in the legal text, the work that I've done with Case, and I've seen it more as public health purpose.
Yeah, normally, the way I'm thinking of population health in this setting would be more like for public health purposes, which tends to be more things that are more like, at least in the legal definition, research can have an exemption for these like kind of data sharing things. And then public health issues can be more things like interventions or things like that, like a nonprofit organization might be doing that's not necessarily research based, but they're usually two separate ideas. Sometimes.
And I think the confusing part for people in my lab is one project in my lab can be either or. So it doesn't have to be that everything is only exclusively one box. So the reality is not mutually exclusive category. So if in one law there's an exception for public health, we can check the box that way. In another law, there's an exception for research, but doesn't have a public health. It's up to you to explain why the project that you're doing fits on one box or another box.
I have a question that's related to the purpose of this research. So the purpose of this research is to demonstrate the disparity between how private information is allowed to be used versus how the population is okay using it, correct?
I think the main purpose of this research is different. And I know I had actually specifically asked Nemenyi to focus on methods and how you would do it, because I think that was the nature of this. But I am finding it interesting that all of you are kind of like, oh, I can learn R, I can do methods. And you're actually more interested in that content part of it, so this is good. What I will say is the main purpose of this is we have, as a whole in our society, everybody is kind of stuck on privacy. And so I think as a data scientist, this is what I think of. Data is like water and you have to have it flow. So that data has to flow so that information can be made from it so that we can use information to make better decisions for a group. And that's kind of the way that I think of the digital world of data flows, right? So if you think of a company that has company data, that's how big companies these days, that's how it works, right? They collect data for what got sold, why people are doing, they do surveys or whatever, and you're using these data sets to figure out next year, we're gonna, make this product and it'll sell best, that's where it is. So it's the same kind of idea, but the issue is, although the private sector gets to do this whole data flow, intelligent way of running a company, at the current status, I don't see government agencies being able to, allowed to do this, because all the laws say privacy, 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 we can't do this, we can't do that, we can't do this, we can't even treat you because, data won't properly flow. On the other hand, it does not mean let's, throw the privacy out, because you don't want mental health conditions, HIV, all of this that's kind of flowing. So the question is, in order to make good data evidence-based decisions for, let's say, population health, and I'm taking we know this, people do this in the private sector, right? How do you make government entities or public decisions do this more is my main big question. So that's why you see my lab, that's what it's all about. So I talk about the methods, I can talk about the infrastructure needed it, but I also, this is the part where we're talking about the law. And this is kind of on what we call LC, ethical, legal, social implications field, where the idea is, as a society, you can't have privacy and have good informed decisions. You can't also throw privacy out and have everything flow. So it's a balancing act, right? So you have to balance the needs of different things to figure out the right point of balance that is fit for, let's say, Texas. So ethically, the idea is you would think Texas residents could have an opinion about the right balancing point between privacy and using data for these purposes or whatever purposes. And that each group of people may have a different opinion about that balancing point, right? You hope that nobody's on the extreme and that it's something in the middle, but even within the middle, there's fine tuning going on, right? So with that in mind, this research is to say, in the US, so that this particular one, if she was talking about, she was using the smaller one, which was the RV community. But the base for these surveys, we did a survey with nationally representative people in the US of 1,000 people, where we asked their opinions to basically help us figure out the right balancing point between privacy and use of data for research, for public health, and for other things. And so that was the goal. And so what we did was, this is actually the secondary analysis. The primary papers do something called conjoint, which is not even here yet at all. We'll cover it another time. But conjoint is a statistical methodology that is used for product development. So do you want a cheap phone, a light phone, right? So when you make a product, there are different things you consider, right? And so everybody's different. Actually, I want my phone to have enough functionality, but not too expensive, not too big, because I have to put it on my. So often human beings make choices balancing. This is a normal thing, except you're not doing it at a very conscious level, right? It just kind of happens. You just end up finding that preference point. And so this conjoint methodology is a way to ask questions so that if you are a cell phone company, you could say, because you don't want to make three different colors, 2 different sizes, if there's too many combos, because it's not going to sell. So this conjoint methodology is a way to ask questions on a marketing survey. This is where it was developed. Based on, if you ask these questions in simpler form, that you can say, hey, what do you like? Pick one. And then you would do the analysis to say, it looks like the right balancing point. The top 3 products that people will buy is a red phone that's like this RAM size, this cost, or whatever. So that's kind of the methodology behind it. And this survey was done in that way. So that's a different analysis that we did that basically showed, so we had basically 3 dimensions. Who's doing the research? For what purpose? And then I forget the third dimension.
Source of data.
Source of data. Yeah. So is it health data, education data, marketing data, right? And then purpose is it for public health, for research, for marketing, for criminal justice. Who was researchers, nonprofits, government agencies, private sector. So those were the 3 dimensions of those things. And if you do combinatorics, it's like 70 some combinations, right? But we did this, and then we came to, here's what the US public thinks is the right balancing between privacy and use of data for these purposes. And the main finding is, you're not surprised, the US public would like everybody, would like the government to use data for research, for public health purposes. They don't like the fact that data is getting used for marketing. Those are kind of what you expect. But the big question was criminal justice. Do you want the government using data to get criminals, like go after criminals? That's not as clear, because although some people might simplify this and go, that's not about me, so I don't mind you using data to go after everybody else. But, that is the basis for. So if you're somebody who's had that experience, you're trying to go through airport and be like, hey, you look like you might be from X country. Are you sure you're not right? That's how it is done. And so some people are like, no way you're gonna touch data, because that's the whole point. So those are the more iffy areas. But you do these kind of surveys, and you expect that over time, people's opinions, the group opinion changes. So that's the purpose of this study. Does that answer your question?
Yeah, but I guess another question I have is, how close does the lab or whoever, the group of people working on these people, get to the lawmakers?
Well, so that's what Jason's sitting right here. He's a JD. Regan is here. She's a JD. So the people in that group, everyone except me and Maheen are lawyers. So we've done different things. So that's a research agenda in our lab. And we use this. We do research to increase knowledge, to say, one of the main findings was to say, we found actually in terms of what data, most people were very comfortable for us to use education data for good informed things. The thing is, Regan knows this, I learned this, but usually in the US, laws around privacy are separated by the type of data. Like health data has HIPAA, education data has FERPA. But to the general public, when we said of the 3 dimensions, what matters to the most, they're like, I don't really care about what data is. I care that I trust you. So the person who's using, who matters the most, right? Purpose was the second. And like, okay, if you really want me to talk about what type of data, I can think about it. They didn't really care. That's funny, because US laws are actually flipped. US laws are around the type of data. And in particular, so when we did all of this, we found that the top most favored is like use education data for research and whatnot. Well, education data, the FERPA law, does not have an exception that allows that use. So the main kicker of the punchline for that paper was, we have found that the US public would like, us to be able to do this activity. Well, the law in the US doesn't allow that. Maybe it's time to change the law. So that was a knowledge generation activity. It got disseminated in a paper. We hope somebody reads it, maybe, does it. So that's one part of this. But we work with the law school and JDs, and so it depends. During this activity, Brian is another person who was a faculty there that we work with. It just happened that there was a privacy. So this is all new. Like Megan is looking. So Megan, you have to correct everything that I'm saying. When I'm trying to teach law to these people, and I'm a computer scientist, so this is what I learned. You have laws and you have policies. I only have no nosy. Apparently, there's something that I'm going to use the word template law. So the thing that was discussed is not an actual law, but it's like so privacy is a very difficult thing. So there was a group of national committee of some kind that said, we really do need to revamp privacy laws like GDP in Europe. And so there's a group of the national people writing a template law that is a template privacy law. So among them, they get discussed, they write the law, draft the law, and pass it. When you pass this template law in this committee, that I guess has some authority, what is meant to do is for the 50 states who, let's say, you have 50 states that kind of in the US is the way it works, right? Every single state, if they had to go do their own research and write their own privacy law, it would be like chaos. So this process, apparently what happens is this group might pass a template law. It's not law anywhere. But then that actually allows for states who want to, pass a privacy law to go pick up that thing. And then that's a very good starting point where they would pick it up and they would edit things or, modify a few things and then pass it in their state. So there was a process of, it just happened to be a privacy GDP thing in the US, which obviously we're all interested. So during this process that happened, the committee chair was at A&M Law School. So it's not that we worked with the committee chair, but we worked with a faculty there. We were all reviewing this template privacy thing. So I'm doing actually, we have a publication. So I'm less involved at this phase. Like I'm just learning. And I actually I felt like I played the role of a doctor when we do clinical studies. We go to the doctor to ask for clinical knowledge so that we can better understand what I'm looking at. Well, I had Brian and Kason asking him about when you do data analysis, like when you're the one using the data, what do you need to see in the law? And so we were having these kinds of debates, and we have a paper on it, which is about this template law around privacy that was passed in the US. And we just got involved at the right time. So we actually did put a clause, that group of us ended up putting a clause in the template law for the general privacy law. And it was a clause around exception for public health purposes. So I guess the people here think it's really, really important that you have a public health exception and a research exception to all these data laws and privacy laws, because to start with, you kind of can, it's not even a privacy thing. If you actually had a biased sample, all the whites are comfortable and say, yes, you can use my data to do X, but all the minority groups are like, no, you cannot, because you never treat me well. And you actually did your study and developed policies around the white, that's not going to work for anyone, right? And so you kind of have to put individual interest to the side for group interest in certain situations. This is where data and public health and research matter. And so we think it's important that all these laws have an exception for public health. Well, this template law that was kind of almost passed and we found out about it. So then Brian went and talked to this faculty and said, can I see it? And we looked at it and all, and you have public comment and everything. So we got involved at the right time. We looked at everything, analyzed everything, and said, you're missing this piece. And then not me, the two lawyers went to the open committee meeting, had their opinions, we wrote official letters, and then the final thing that got passed did have a public health exception. So we did have impact on something. Now you hope and then after that year, that got adopted by X number of states, like they were reviewing this thing, because the privacy part. So I don't know if when they got accepted at the state, whether our public health exception made it to the very end. Do you know much about this?
I don't know actually anything about what you were just talking about, but it sounds really interesting. Do you remember the name of it?
So it would be, if you look at Kason's publication list, he has a publication in Yale Law. It's a law. Those journals are different, but if you pick that up, it's got all the details. And
Okay.
there's a initial for the template law. So it's not the actual law, but it's a law that you pass and that it's there for the 50 states to adopt it. So that keeps in the US more consistent laws as we get to states.
Okay, thank you.
So can we,
Oh yeah, I just also have another question.
yeah, so are we, no more video?
We're actually recording.
Yeah, we should cut the video at some point and have an internal conversation.